Welcome, fellow aviators. Today, we're going to demystify holds by use of the magic number method. Reminder, there is no substitute for quality flight instruction from a competent professional. Please use caution and obtain the services of a flight instructor while implementing the concepts of this video. I have holding instructions for you. Advise ready to copy. These are the words that make many instrument pilots very nervous. Even most seasoned professional pilots, if they are honest with you, will say that performing a non-standard hold without the benefit of an autopilot would be really uncomfortable. There are hundreds of thousands of check ride failures and pilot deviations that speak to the confusion that surrounds these complex procedures in the aviation industry. However, it doesn't need to be that way. So, if complex holding instructions still make you a little nervous, stick around, and I will show you how to demystify holds by use of the magic number method. Holds are used to slow an aircraft's progression for traffic separation or airport delays. They are also used to help aircraft get established on instrument approaches and even to safely gain altitude on some departure procedures. To safely use this versatile tool, we must first understand the anatomy of the hold. The first piece of the hold is called the fix. The heart of the hold is the fix. This is a fixed position from which the pilot will reference the procedure. The fix can be a nav aid, a distance, a GPS location, or a GPS waypoint. The backbone of the hold is the inbound leg. The inbound leg has a length of 1 minute long as a standard, but can be adjusted to a distance for GPS holds. The outbound turn is initiated once the fix is crossed. This turn should be a standard rate 180-degree turn and should take 1 minute to execute. The standard direction of turn is right. The outbound leg is flown using a heading and should be parallel to the inbound leg and 1 minute long, or the given GPS distance in no wind conditions. The inbound turn is initiated upon reaching 1 minute outbound or at the given GPS distance in no wind conditions. This turn should be a standard rate 180-degree turn and should take 1 minute to execute. Rollout should occur on course for the inbound leg. The protected area is an area around the hold that has been carefully surveyed to ensure it is free of hazards. Maximum holding speeds are enforced to ensure aircraft stay within the protected area while holding. These speeds vary based on altitude. Now that we understand what a hold is, the next step is figuring out the hold entry. Hold entries are broken up into 3 sectors based on the approach angle to the fix. Pilots should use the entry appropriate for the sector they are approaching from. When approaching from the teardrop sector, the pilot should cross the fix, turn 30 degrees from the inbound leg, fly outbound for 1 minute, turn back to and intercept the inbound course, and then track back to the fix. When approaching from the direct sector, the pilot should cross the fix, turn to the outbound heading, fly outbound for 1 minute, turn back to and intercept the inbound course, and track back to the fix. When approaching from the parallel sector, the pilot should cross the fix, turn to the outbound heading, fly outbound for 1 minute, turn back to and intercept the inbound course, and track back to the fix. Now that we have the hold anatomy and entry procedures down, the next component is understanding hold clearances. A hold clearance is made up of 7 components. 1. The cardinal direction. The cardinal direction is the location of the inbound leg. This is not the location of the entire hold. Sometimes pilots will mistakenly turn the wrong way because they envision the entire hold instead of just the inbound leg. Example, hold northeast of the fix 010 outbound. Remember, no instructions for left turns were given. Standard turns are to the right. The correct hold with right turns should look like this. The inbound leg is northeast of the hold, even though the hold is northwest of the fix. The second component to a hold clearance is the fix. The 4 fix options are broken up into 2 types: location fixes and DME fixes. The third component to a hold clearance is the directional information. There are 360 radials that can be identified proceeding out of a location fix. Each one is identified by its numerical identifier. Directional information can be given about this radial in 2 ways: inbound and outbound. The fourth component of a hold clearance is the direction of turn. Holds can be performed with turns to the right or the left. Right turns are standard, and this portion of the clearance may be omitted if standard turns are expected. Left turns must be specified. The fifth component to a hold clearance is the leg length. The standard leg length is 1 minute and is based off of the inbound leg of the hold. If the fix is a DME distance or a GPS fix, the leg length may be in distance instead. If leg length is omitted from the clearance instructions, it is a standard 1-minute leg. The sixth component of the hold clearance is altitude. Holds are usually performed at a fixed altitude, and in these cases, altitude information is not given. However, if the hold is used to climb or descend the aircraft, these instructions will be a part of the holding clearance. The last component of the hold clearance is your expect further clearance time. It is not uncommon for controllers to forget to give the pilot an expect further clearance time. In these cases, the pilot should always request one. You need to know how long you will be holding for fuel planning purposes. Note: if the fix used for the hold is a part of an instrument procedure, the controller may use the phrase "hold as published" to minimize radio congestion. In these cases, the pilot must obtain the specific hold information from the approach procedure. Now that we understand the anatomy of the hold entries, and hold clearances, the last component is understanding the effects of wind on the hold and how to apply wind correction. The hold is designed to be performed over a certain area on the ground. Wind can affect the ground track of the aircraft and blow it out of the protected area while holding. To prevent this from happening, there are 2 types of wind correction that must be applied: crosswind correction and headwind-tailwind correction. A crosswind will affect 3 legs of the hold: the outbound turn, the outbound leg, and the inbound turn. The inbound leg will remain unaffected because the aircraft will have positive course guidance when on course. To correct for a crosswind, apply 3 times the wind correction angle to the outbound leg to account for the 3 legs the wind affects. Obtain the wind correction angle while flying the inbound leg, turn outbound and accept wind effects. Apply 3 times correction angle to the outbound leg, then turn inbound and allow the wind to push you on course. Don't forget to apply the original wind correction angle once you're re-established inbound. Headwinds and tailwinds will affect the ground speed of the aircraft. They primarily affect the inbound leg and the outbound leg. Thus, the effects of the headwind-tailwind are doubled. To correct for the headwind or tailwind, calculate the difference between your desired time and your actual time. Then times or divide it by 2. If the time is too big, use division to make it smaller. If the time is too small, use multiplication to make it bigger. Then add or subtract from your outbound leg. If the time is too big, use subtraction to make it smaller. And if the time is too small, use addition to make it bigger. In this example, our inbound leg only took 14 seconds, not the 60 that we normally want. That's 46 seconds too fast. Times 46 seconds by 2 to get 98 seconds added to the outbound leg. Add 98 seconds to the already 1-minute outbound leg to find a new time of 158 seconds outbound required to obtain a 1-minute inbound leg in these wind conditions. Now that we understand the fundamentals of holding procedures, It is easy to see how pilots could get a little lost while trying to perform one, especially when considering that they are most frequently performed in turbulent, low visibility conditions in busy airspace. They are usually unexpected and given with little time to figure it all out. As if all of that were not enough, you may also have to fly them using only an HSI or similar equipment. That is why most pilots could use a little help from the magic number. The magic number is the 8th component of a holding clearance. It will not be given by ATC, but must be calculated by the pilot. This extra step does add a small amount of workload to the pilot, but is worth the effort because it answers every question the pilot will have for the rest of the procedure. Almost like it's magic. Let's look at a hold clearance to see how it works. The pilot must compare the first and third sections of the hold clearance and ask themselves if they match. Is 360 north? If the answer is yes, then 360 is your magic number. But what if they don't match? The magic number will always match the cardinal direction. Is 180 north? Of course not. So flip 180 180 degrees. This can be done with the +2 -2 rule. Add 2 to the first number, then subtract 2 from the second number to find your magic number of 360. Or you could simply look at your HSI. Use the course deviation indicator needle or an imaginary straight line to transition from 180 across the face to the magic number. And 360 is your magic number. If the directional information is not the inverse of the cardinal direction, the controller has made a mistake. Ask for clarification. They are human too, and this does happen from time to time. Now that we know how to find the magic number, how do we use it? Let's start with figuring out hold entries. You must be flying towards the fix to hold there, and you must be flying towards the fix for the magic number to work. Once you are inbound to the fix, start by drawing the inbound leg of the hold on the HSI. Where should you draw it? Easy. Start at the magic number. Next, draw the turn, and complete the rest of the hold. Now mentally fly the aircraft to the fix and ask, what entry makes sense? Did you think teardrop? Good job. This is the teardrop zone for a standard turn hold. Don't waste mental energy worrying about making it exactly 70 degrees. Anything in this quadrant will work. Let's try another one. Is 150 northwest? No, so the magic number is 330. Draw the inbound leg, perform the left turn, and fly to the hold. What entry makes sense to you? Still a teardrop entry? That's right. Teardrop and parallel switch sides for non-standard turn holds. I changed the cardinal direction, the nav source, the type of directional information, the direction of turns to non-standard, the leg length, the location of the entry quadrant, and you still could easily determine the correct entry? Almost like it's magic. But what if more than one entry makes sense? How do I choose? Well, that problem doesn't happen with preferred entries. Teardrop, parallel, then direct. Choose the most preferred entry available. Due to the number of turns and distance from the protected area, teardrop entries are most preferred, then parallel entries, and lastly, direct entries. To show you why, let's try both options on this hold entry. For this example, we could do a teardrop hold, and it would look like this. Or we could do a direct hold, and the entry would look more like this. Obviously, the teardrop does a much better job allowing us to complete a less complicated, more protected hold entry. That's why it's preferred. Now that we understand how to select the correct hold entry, the last component is execution of the hold entry. For this, we will use the 5 T's of instrument flight: turn, time, twist, throttle, then tuck. The applicable 5 T's should be executed every time you cross a fix in instrument flight, not just holds. Let's take a look at one more example to see how the magic number helps us execute the hold entry. So here's the hold entry you received. First, center the CDI to find your inbound radial. Then set your heading bug if you have one and turn inbound to the VOR. Calculate the magic number and determine the entry that's appropriate for this hold. In this case, it would be a direct entry. Cross the fix and execute the 5 T's. First, turn to the magic number, 090. Once you reach the magic number, start your timer. Next, twist the tail of the course deviation indicator to the magic number. Then reduce throttle as necessary to remain below the appropriate maximum holding speed. And lastly, report to ATC that you have entered the hold. Upon reaching 1 minute outbound, turn to intercept your inbound course. Note, the aircraft is not considered established in the hold until the inbound course has been intercepted. That is why the pilot should report having entered the hold when completing the 5 T's, rather than risk forgetting the report because they waited for this higher workload time of intercepting the inbound. ATC does not really care if you are established. They simply want to know when you have stopped moving forward and transitioned to executing the hold procedure. So that's what the 5 T's look like in a direct entry. If the magic number happens to be in the teardrop zone, the first turn is 30 degrees to the top of the magic number. The other 4 T's are the same. Turn 30 degrees to the top of the magic number, in this case 060. Once reaching 30 degrees to the top of the magic number, start your timer. Then twist the tail of the course deviation indicator to the magic number. Next, reduce throttle as necessary to remain below the appropriate maximum holding speed. And then report to ATC that you have entered the hold. If the magic number happens to be in the parallel zone, the first 2 turns must be made opposite the direction of the hold. The other 4 T's are the same. So, for a parallel entry, first turn opposite the hold to the magic number. In this case, that's a left turn to a heading of 090. Once reaching the magic number, start your timer. Then twist the tail of the course deviation indicator to the magic number. Reduce the throttle as necessary to remain below the appropriate maximum holding speed, and then report to ATC that you have entered the hold. Remember, once you have reached 1 minute outbound, the second turn needs to be the opposite direction of the hold. In this case, that's 1 more left turn. Don't forget that for a parallel entry, the inbound re-intercept angle must be at least 45 degrees to prevent crossing the fix before course interception. So remember, all you have to do when you get a holding clearance is write down the 7 components to the hold, calculate the magic number, determine the appropriate entry, execute the 5 T's, and then apply wind correction angle once you're established in the hold. And that is how holds can be magic. Thanks for watching. Please like and subscribe, and I'll see you on the next one.